11.3 is going to be exactly like 11.2 was. So here we go, independence. You are interested in investigating whether the type of computer a person primarily uses and the type of car they drive are dependent. The table below shows the results of a survey. So is there any connection between the kind of car you drive and the kind of computer you own? Like if you drive a sedan or an SUV or a truck, does that affect like whether you like to use a tablet or a notebook or a desktop? What's a notebook? How's that different than a tablet or desktop?
A tablet is like...
I know what a tablet's like what I'm using, right? And that's a
laptop. Like
so what?
Like a laptop.
It's this.
So what's a notebook?
This.
Just like a,
Isn't that a laptop?
But isn't that what, like a laptop notebook?
Yeah, like laptop.
Or is it talking about like an actual...
Oh, you're right. Yeah, notebook is laptop, huh? You're right. And then there's desktop. Thank you. Not that kind of notebook. That's the low-tech notebook. All right, so, yeah, notebook. I've got notes. All right. So, anyway, do you think there's any connection there? Do you think people that drive trucks love tablets more or less? Truck drivers are a little more sturdy, right? So maybe they want the desktop. I don't know. Well, who knows if there's any relation? It's kind of a silly question. But anyway, so what we're going to see is if there's this one doesn't thrill me. Is there a more interesting one? Tennis, swimming, basketball, how old you are? All right. We'll do this first one. I'll quit jumping around. All right, so we're going to see if there's some kind of connection here between these. Is there some kind of connection? So how do you do that? What we're doing, if you look on your exam 2 notes, I'll go back here to the exam 2 notes. We're looking on number 11, test for independence. We're wondering if type of truck and type of computer are independent or dependent, meaning do they affect each other or not? How do you test it? H0 is they're independent. H1 is they're dependent. And you put it in your calculator as a matrix, and then you choose the chi-square test. Just exactly like 11.2. So first off, what's HO every time on a test for independence? They're independent. Well, here, I'll just write independent. Independent, meaning they're separate. They don't affect each other. The kind of truck you own has nothing to do with the kind of computer you own, which may be the case. H1, the opposite, is dependent. They do affect each other. They are dependent on one another. So we'll see what the truth is here, at least if this data is real. Okay, and it's weak evidence and strong evidence like usual. And so what is the correct statistical test to use? Well, independence, obviously. What are the null and alternative hypotheses? The null is independent, and the alternative is dependent. Pretty easy so far. And now you can put this in your calculator as a matrix. Remember how you do that? You hit second matrix, and that's like on the left side right above the X minus 1 button, right? Isn't it? No.
Yeah. That's top of the X minus 1 button.
Oh, yeah, it is. Hit second matrix, which is on the left edge, second matrix, and then you got to choose the size. This matrix is a 3 by 3, so on the size thing, you got to go 3 by 3, hit enter, and then you just put in these numbers. Every time you put in a number, you hit enter afterwards, right? And every time you hit enter, it saves it, so that when you're all done, then you can go second and quit, and it's got it saved. So do that if you have not. Next sheet here. And then what do you hit after you do that? It says on the independence test there that you go to stat, tests, and you do the chi-square test, which looks like an x squared, but it's called chi. It's a Greek letter. So go there. So chi-square test. Boom, calculate. And so I'm getting chi-square equal 5.555. 577, blah, blah, blah. And a p-value is 0.234, was that 87? So I'll put it over here. So test statistic, they want 3 decimal places. So that's the chi-square. So we've had t and z, now we have chi-square. That's our new test statistic. 5.556. We'll have to round it to 3 decimal places. And the p-value wants 4. So that's going to be 0.2349. 87, so rounds to 9. All right, and so you know what we do from here. What's the significance level, did they say? Oh, there it is, 0.10. Significance level is 0.10. So the p-value, is that higher or lower than 0.10? Yeah, 23 is higher than 10. So that's higher. The p is not low. So the HO does not go away. Right? We fail to reject the HO. We fail to reject the HO. We keep the HO. Right? We agree with independence. We cross out the H1. We say the evidence is weak. It's not strong. Looks like car style and computer style are independent. They don't really affect each other. Doesn't really matter. One thing doesn't really affect the other. They're independent. So independent, we keep HO, which is independent. Weak evidence. Not sufficient evidence. Not enough evidence. All right, so based on, the p-values, we accept the null, not accept, fail to reject. Fail to reject the null. So the final conclusion is what? There is insufficient evidence to conclude that the distribution of computer types is, there is insufficient to conclude the computer type and car type are dependent. Yep, there it is. There's insufficient evidence to conclude they're dependent, so we assume they're independent. Questions? Now it's independence, but it's the same thing. So I'm going to move on to question number 2. If you're good with that one, I don't want to rush too fast, so let me know. Question 2. The data below shows sport preference and age of participant from a random sample of members of a sports club. Is there evidence to suggest that they are related? So in other words, does what age you are affect what kind of sports you play? Like in the over 40 category, do you tend to play one sport more than the other? I'm in the over 50 category now. I tried to run around in a soccer field weekend before last with some young children and my kids and some other kids. My back was sore for a while. All right, so anyway, so are these variables, your age and your sport, are they connected? Are they dependent, independent? Same test. It's just HO is in every time. Now, which is nice. We don't have to try to read real careful for some kind of special claim wording. It's just HO is the same every time. It's independent. H1 is dependent. And you know what we do. We put that in our calculator in a matrix. And then we do the chi-square test. Put a matrix into your calculator. What size is that? Do you go down first or across first when you give the size for a matrix? Down. Yeah, I don't know why they made it that way. They could have gone it the other way. They just said you go down first. So it's down 4, across 3. 4 by 3. Down and then across. So 4 by 3. And so And so put that in your calculator, and then second quit after you put that matrix in there, and then go to your stat test and do the chi-squared, hit the buttons, and so this is a test for independence. The HO is independent, the H1 is dependent, same thing every time. And when you hit the buttons on this one, HO again, independent. H1 dependent. So when we hit the buttons, the test statistic for this data, what am I getting? I got a chi-squared value that is 3 decimal places, 698. That's what I'm getting on mine. And a p-value that is 4 decimal places, 0047. All right, so is my p, what was the significance level? 0.10 again. So they want 0.10. So that is certainly below 10. 0047 is certainly below 10. So the p is low. So if the p is low, then the HO must go. Go away, that is. Go far, far away. So cross out the HO. And you know how it is, weak evidence and strong. So cross out the HO in his weak evidence, gonzo. We keep the H1 in his strong evidence. So our conclusion is H1, which says they're dependent. They do affect each other. Your age affects what sport you play. They're dependent and they're strong or sufficient evidence, statistical evidence backing that. When you get older, your sport has to change. I think that's for sure true. So we rejected the null, didn't we? Right? The HO went away. We rejected the null. So you guys know all this stuff quite well now. There is sufficient evidence to conclude that age and sport are independent. No, we concluded dependent, didn't we? H1, dependent. There we go. Sufficient evidence to conclude they are dependent. What could be easier? Well, probably a lot of things, but it's fairly easy. Right? Are we good there? Going to jump around. All right. So does whether you're a man or a woman have anything to do with what kind of major you are? Do you think, are there a lot of females majoring in engineering? Not many. Not many. I was in those classes for a while. That's why I bailed out. I had to meet a wife somehow. I'm just joking. But and I teach future elementary school teachers a lot of times. I teach some of those classes sometimes. Not many men in there. There's always a couple, but not many. So yeah, it certainly can affect, huh? So I would suppose that there's going to be strong evidence that these variables affect each other. I don't know, maybe not, because they're choosing pretty broad categories. So anyway, let's see. You know what we do? HO is independent, and H1 is dependent. They affect each other. They don't affect each other. All right, let's crank through it. So you know what we do? Put this in your calculator as a matrix. What size is that matrix? We go down and then across. So it's 2 down, 4 across, like that. It's 2 by 4 matrix. Put that in your calculator and then do the chi-squared. You know how the evidence goes. Weak evidence, strong evidence. Like that. So put it in your calculator. And I just did it. So we're doing independence test. HO is that they're independent. H1 is that they're dependent. And then, so let me write it over here. HO, independent. Independent. H1 is dependent. And you know it's weak evidence and strong. Okay, and when we do the test, I got a chi-square equal to 5.3, they want 3 this one, 304. So it goes right here, 5.304. And I got a p-value that came out to be 0.1508. 1508. Okay, so what is the significance level? 10%. So that is greater than 10%, isn't it? My p-value is greater, my p is not low, so the HO does not go away. So I keep the HO, get rid of the H1. Evidence is weak, independent, so we fail to reject, don't we? We keep the HO, it does not go away. Fail to reject the null. Fail to reject the null. There is weak evidence, so not sufficient. It's going to be one of these insufficient ones. Insufficient to conclude No. Insufficient to conclude dependent. That's what we're testing. It's insufficient to conclude dependent, so we continue with the assumption of independence. So in this data case, we're saying they don't affect each other, the broad categories they chose. All right, I think you got it. It's exactly the same, isn't it? And that was the last problem. So if you're good, I'm going to move on to the quiz. No, to 11.4 and then the quiz.